Alrighty. So we'll start here today with questions from the previous assignment or assignments. If anybody's got them, you can say aloud or you can type them into the chat. Either is okay. If there aren't any, we can obviously just get started or whatever. Yes.
Could you do number 6 on homework 8, please?
Sure. Let me just copy that in there. This is homework 8, number 6. Okay. So the first thing I'm going to do is I'm going to locate the vertex. So the x-coordinate is going to be found by doing negative b over 2a. So that's negative 4 over 2 times 1, which is negative 2. And then when I find the y-coordinate, I'll just do that by plugging negative 2 in for the x's. When I do that, I get 0. So I'll make my xy table with the vertex in the middle. Then I'll just pick 2 x's that are bigger and 2 x's that are smaller. And to find their corresponding y-coordinates, I'll just plug them in. When I plug negative 4 in, I get positive 16, negative 16, and 4. So that gives me 4. When I plug negative 3 in, I get positive 9, negative 12, and then positive 4, which is 1. And because these are symmetric, I know that they're all just kind of right in a row. So then we just plot these bad boys. And you get something that looks kind of like that, a neater version of that, but that's the gist of that one for number 6. Number 4 on homework 8. Oh, Amy, are you happy with what we did there before we move forward?
Yep, thank you.
No problem. Okay. So number 4, we're asking to find up or down the axis of symmetry in the vertex. So here I noticed that this is vertex form, or not vertex form, intercept form. So the A here is 2. So since that's positive, we know we're opening up. Since it's in vertex form, I know it's going to be P plus Q over 2. So remember, the P is the opposite, and the Q is the opposite. So P is negative 10 and Q is negative 8. It's negative 9 for my axis of symmetry. So that's also the x-coordinate for our vertex. To find the y-coordinate then, we just plug that in. So negative 9 plus 10 is 1, negative 9 plus 8 is negative 1, and then times 2 is negative 2. So we have negative 9, negative 2 for our vertex. Maria, are you happy on that one?
Yes, thank you.
Of course. Number 7. Okay. So I recognize that this one is in vertex form. So the vertex is very easy to get. The vertex is just h comma k. So in this case, that's 3 and 5. Just 3 and 5. Remember, the h is the opposite of the opposite sign that it appears. So I'll make my table with the vertex in the middle. And I'll pick 2 values less and then 2 values more. And then we'll just plug these in. So when I plug 1 in, 1 minus 3 is -2. -2 squared is 4, but then we make it negative, so we have -4. And then plus 5 is 1. When I plug the 2 in, 2 minus 3 is -1. -1 squared is +1, but then we make it negative, so I have -1. Plus 5 is 4. And since we picked things symmetrically, we can fill those in for free. So we have 3, 5, 2, 4, and then we have 4, 4. That's too high, I think. 5 should be like there. And then we have 1, 1, and then 5, 1. So it looks like this. Mackenzie, happy there?
I need it on homework number 8 on homework 7.
Oh!
But I think someone else needed this one.
Yeah, I did this one. Thank you.
Oh, Jack. Oh, sorry.
Thank you. Yeah, thank you.
That's okay. All right, homework 8. What else is on homework 8? Number 8 is the other one on homework 8. Then we'll move to homework 7. Sorry, I confused myself. All right, intercept form is this one. So to find the x-coordinate of the vertex, I'm going to do p, opposite of 3, plus q, the opposite of -5, over 2, which is just 1. To find its y-coordinate, then we'll just plug it back in. So I have 4, and -4 is -16, times 1/2 is -8. Oops. So I'll put that in the middle. And then we'll go and pick some more x's. All right, when I plug -1 in, I have -1 plus 3 is 2. -1 minus 5 is -6. 2 times -6 is -12. Times 1/2 is -6. When I plug 0 in, 0 plus 3 is 3. 0 minus 5 is -5. 3 times -5 is -15. Times 1/2 is -7.5. And then we can just fill that rest of that stuff in. And we're ready to plot. So I have 1, -8, 0, -7.5, and 2, -7.5. And then, go away. 3, -6. So maybe like right there. And then we have -1. -6 is about there. So there we go. Natalia, or Natalia. Natalia. Are we happy there?
Mm-hmm.
Of course. Of course. Okay. On to homework 7 now, right? Okay. And then we need to look at 6 and 8. Okay. So Mackenzie, this number 8. So we'll start noticing that this is in vertex form. So the easiest way to solve something like this is to use the reverse order of operations. So I'll start by subtracting 18 from both sides. -6 minus 18 is -24. And we'll divide both sides by 5. I'm going to leave that as a fraction. And we square root both sides. So when we square root both sides, we get a plus or minus. And then we subtract the 7 from both sides. And as long as we're at it here, since I'm square rooting a negative, I know that creates an I. And there's a final answer. It's not the best version of our final answer because we should be able to simplify this radical a little bit. So the square root of a fraction I can think of as the square root of 24 over the square root of 5. And I know 24 is the same thing as 4 times 6, right? So the square root of 24 is the square root of 4 times the square root of 6. So I can make that 2 square root of 6 over the square root of 5. And then we don't like to leave a radical in the denominator. So to fix that, we just multiply the top and bottom by the square root of 5. That's going to give me negative 7, 2 square root 30, 6 times 5, over 5, square root 5 times square root 5 is square root 25, which just becomes a regular 5. We'll write the I at the end. And this is like our best version of our answer. This I would still accept for credit on the test or whatever. But if you're doing like a multiple choice standardized test, this is not the answer that they would be listing. They would give something that looks like this. Mackenzie, are you good with this one?
Yes. But does it matter if you put the I before or after? Like, does that matter?
No, in the same way that, like, if you write x times 3 or 3 times x, it doesn't really matter, but usually we write it this way with the x second. Usually we like to write the I last, but it doesn't really matter. Are you happy with that explanation? Okay, I hope so. If not, you'll let me know, right? All right. And then, Amy, you wanted to see number 6, correct?
Yes.
Good. So this one I could think of either as a standard form problem or a vertex form problem. It doesn't really matter. I'm going to think about it as a vertex form problem because it makes life much easier to just do this using the reverse order of operations. Not that using the quadratic formula would be difficult in this case, but it's a little bit more work than we need to do. So I'll start just by subtracting 17 from both sides. We'll divide both sides by 5, and we'll square root both sides. And since we square root both sides, we get the plus or minus. And since we're square rooting a negative, we know that makes an I. So we'll just call that x equals plus or minus I square root 3. And here, Mackenzie, I wrote the I in front just because so it wouldn't be confusing about whether the I was underneath the square root or not. And I do that just when I'm writing things by hand because this is not the same thing as like this. And it's easy to like, you know, when you're writing the square root to kind of goof that up. So I put the I in front there just so there's no ambiguity about whether the I is under the square root or not. And since it doesn't really matter where the I goes, I do that for clarity's sake when it's when necessary. As to your earlier question, not that I'm calling you out in particular, but you asked about like what order do these things need to go in, and I just thought it would be a good opportunity to mention that. Okay. Any last takers before we move on? Okay, then. Very good. The plan for today, we have one last topic to talk about in this chapter, and that is modeling. And the idea here when we talk about modeling is we want to take points, or really information, about a quadratic function and create its equation. So when we say equation, we mean vertex form, intercept form, or standard form equation. So there's really three situations that we can run into here. The first situation is if you're given the vertex and then some other point. Here we'd want to use vertex form. Let's look at an example. Try that. So since we're given the graph has a vertex of -2, 3, and it passes through the point -4, 11, we know we're going to use vertex form. And I remember from vertex form that the vertex is h comma k. So I know immediately that I have an h of -2 and a k of 3. Just as a sidebar here, when we have our final answer, we need a value for a value for h, and a value for k. Right? So when we write our equation, what we're looking for is that y equals something in for a, x, something in for h, and then something in for k. We are 2/3 of the way done, though, almost here immediately, right? Because we have the value for h and k just by looking at the vertex. The last thing that we're going to need is to figure out the value for a. To do that, we're going to use the piece of information that we haven't used yet, namely this other point, which can be thought of as an x and a y. So if I plug that x and y in with the h and k, I'm going to be left with an equation that I can solve because it has just one variable in it. So I'll start by subtracting 3 from both sides. And then -4 minus a -2 is -2. And -2 squared is 4. If I divide both sides by 4, I get a is equal to 2. So now I have values for A, H, and K. So if I put that all together, I have y equals 2 times x plus 2 squared plus 3. Notice that your final answer has the x and y variables there, not the 11 and negative 4. Your final answer should always have an x and a y. It should be something you could graph, so it should have an x and y in it. The letters x and y, not the values for x and y. Any questions on what we did there? Hopefully that feels pretty familiar. It's very similar to the process we used when we modeled absolute value functions way back at the beginning of the semester. The second situation is where we have two x-intercepts and another point. In this situation, we're going to use intercept form. So let's do a quick example. So here you're given the points 4, 0, 6, 0, and 7, negative 4. And notice right away, since these 3 points, or these 2 points, excuse me, have y coordinates of 0, I know that these are x-intercepts. So I can tell, even though I was listed 3 points, I know that 2 of them are x-intercepts by their y-coordinate being 0. So I'm going to use my intercept form equation. Y equals a times x minus p times x minus q. And I remember that my x-intercepts are special because they give me the values for P and Q. So again, to write my intercept form equation, I need 3 values. I need the value for A, for P, and for Q. Right away, without having to do much, we're 2/3 of the way done because we have our values for P and Q just from the x-intercepts. To find my value for A, the last piece that I need, I'm going to use this other point that we haven't used yet. That other point is an x and y. Just like before, I'm going to plug in those values for x and y and P and Q and use that all to solve for A. Oops. So, 7 minus 4 is 3, and 7 minus 6 is 1. 3 times 1 is 3, so I have 3a. And if I divide by both sides by 3, I get a is negative 4/3. So that's everything I need. I have A, P, and Q. And that's all there is to it. Is that okay there? Good. Again, not so difficult, right? The third situation is if you're given any 3 points. So if you don't have one of these other 2 special situations, you're probably just going to be given 3 points. If that's the situation, we're going to just use standard form. if you allow me just one moment, I'm going to generate a quick example that has decent numbers in it. I don't want it to be like stupid numbers, so I'm going to generate a quick example on the side here so that I can make a problem that's not going to be super duper annoying to do. Okay. So let's say we have the points -2, -33, 1, -6, and then 2, -9. Okay. If we look at these, we notice there's nothing special or unique about these 3 points. None of them are x-intercepts or anything special there. So we're just going to use our standard form to do this. And to write our standard form equation, we need a value for A, a value for B, and a value for C. Now, there's no relationship between a generic point and these coefficients A, B, and C. So what we're going to do is we're going to think about each of these as an xy, and we're going to use them to create a system of 3 equations. So plugging the first xy in, you get this equation. When I plug the second xy in, I get that equation. When I plug the third xy in, I get this equation. So that's going to be the system that I'm going to solve, because I have 3 variables to solve in one equation, right? The only way to deal with that is to create a system of equations, which is what we've done here. Now, if you recall back to the previous chapter, what was the easiest method we had to solve a system like this? Do you guys remember? Well, I would use Gaussian elimination to solve this system, because I can do it all on my calculator and it's pretty fast and easy. For me to do Gaussian elimination, though, I need to rearrange this so it's in a little bit easier form. So I'm going to rewrite things with the equal sign on the right-hand side, and I'm going to simplify things going on in here. So -2 squared is 4, and then -2b, and then 1c is equal to -33. I'm going to write the 1 there in front of the c, because I'm going to need to turn this into a matrix in a moment, and I need the coefficients. And if I don't write the 1 there, sometimes I forget. So I'm going to put 1s in front here, just so I remember to put 1s when I go and make my matrix. Does somebody have a question? I hear something going on in the background there. I don't know if somebody just accidentally unmuted themselves or we're getting ready to ask a question. Okay. Is everybody okay with what I did there, though? I didn't do much, right? I just simplified some stuff and rearranged the equation, putting the equal sign on the right-hand side instead of the left. Okay. Now that I have it in this form, I can turn this into a matrix where I'm just going to take the coefficients from my system to make a 3x4 matrix. So I have 3 rows and 4 columns. And we just do the RREF command on this matrix. and that should output my answer. So just to remind you guys how to do that again, let me fire up old Graphy McGrafferson here, and we can do this. So we'll go second, and then press the X and the -1 button to open the matrix menu. I'm going to move over to the Edit tab. I'll set the dimensions of my matrix to 3 by 4. It's already been done. And I'll type in my new coefficients. Just pressing Enter between each one to toggle to the next spot. Okay. Once I have all of my entries entered into my matrix, I'm going to exit out by pressing second and then the mode button. Now I need to retrieve the command rref. To do that, I'll press second and the X and the -1 button to return to the matrix menu. This time I'm going to move over to the Math tab using the right arrow key and scroll down until I find the command rref, making sure I pick rref and not just ref. So once I've picked the command rref, I'm going to do that on that matrix I created that I called matrix A. To retrieve that matrix, I'm going to go back to the matrix menu by pressing second and X the -1. And then from the Names tab, I'm going to select the matrix that I just entered, which was matrix A. Close my parenthesis and press Enter. So that output the matrix. This, which tells me my values for A, B, and C respectively. Oops, that was a -9. I just didn't copy it down right. Pretty positive. Yeah, it was. And that's all she wrote. So that's the 3 kinds of modeling problems that we're going to worry about here in this course. Does anybody have any questions about what we've done here? Okay. So following this lesson, you guys should be able to do homework 9, what you can find in the content library. So there are the problems for homework 9. So there's a couple of examples of each type. In the next class, we'll take questions, if you have any from homework 9, talk about the test format, give you the test review and answer key, and let you guys spend the rest of that class period kind of working on that stuff. Friday, we'll take our Chapter 4 test. And we'll do it kind of the same way we've done the homework quizzes, where I'll end up emailing rather than putting in the content library, but I'll email you the chapter test. And you can do it in OneNote or on paper. Convert your work into a PDF and then submit it to a Dropbox on PowerSchool. But we'll talk more about that on Wednesday. Does that sound good to everybody? Great. So that's all I needed to do today with you guys. So before you go, if you haven't said hi or here into the chat for attendance, please do that. And before you go, before you go, I have to mention one other thing. Sorry, we haven't done the homework quiz for this chapter yet, right? That was almost a big oopsie on my part. So the homework quiz, this homework quiz is going to be a little different. What I did is I made a quiz on PowerSchool for this one because it's a factoring quiz. So if you go to PowerSchool and you go to our class page, my internet is so slow. And you look at the bulletin board. You'll see on the bulletin board is this factoring homework quiz. So this quiz is open and available until 12:35. So you guys will have, 40 minutes or so to get this done. It's timed, and you only get 10 minutes to do it, but it's all factoring problems. So it's a fill in the blank quiz. So you're going to be given a quadratic and ask for the factored form. You just type your answer into the blank. But it's going to be kind of picky about how you format your answer. So the first thing is you can't have any spaces in your answer. So like this answer, x minus 2 times x plus 3 will be counted as correct. But this answer, x minus 2 with a space and then x plus 3 would be counted as incorrect. Additionally, you have to use a subtraction symbol rather than plus and negative. So again, x minus 2 times x plus 3 is correct. But if you wrote x plus a negative 2 and then x plus 3, it would mark that as incorrect. The order in which you write your parentheses doesn't matter. So I have it set up to do that at least. X plus 2 times x plus 3 or x plus 3 times x plus 2 are both acceptable and should be both marked correct. If something is not factorable, I need you to write NF. It doesn't need to be capitalized. Capital or lowercase won't matter there. And you get 2 chances for each problem. If it takes you 2 tries, though, you only get half credit if you get the second try correct, is the way things are kind of set up. And to take it, you'll just click the link and it'll take you right in. When you're taking it, when you enter your answer, you have to make sure you press like OK or whatever right next to it after you've filled in the blank for it to record that answer and move on. It'll tell you immediately if that's correct or incorrect. And then when at the very bottom, there's like a submit or something where when you're actually finished, you press that and then it'll record your score, whatever, for me. Have you guys done a fill in the blank quiz on PowerSchool before? I'm guessing some of you probably have for other classes. It's the first time we're doing it here, but it's a good way for me to do it because it's easy for it to check the factoring. So that there's a 10-minute time limit on it, by the way. So some of these quadratic problems you can use will be factorable with the shortcuts. Some of them you'll have to use the long way. Some of them are not factorable at all. My suggestion to you is to have like a pencil and paper handy, so if you have to do something the long way, you have something to write it down, because there's just a little blank to fill in. So you'll want to have like a separate sheet of paper so you can make some scratches on it, because if you have to do the long factoring, it's not very easy to do that in your head. Now, you guys are released. Before you go, if you can type bye into the chat for attendance purposes, that would be fantastic. And I'll see you guys on Wednesday. I'll be around if you have any questions that you want to ask after class. But have a good day. Okay, guys? Bye.
Thank you. Bye.
You're welcome.
Thank you.
You're welcome.